Hi, everyone. Thank you for joining us today for the Introduction to Mass Timber in Construction webinar. My name is Alex Robinson, and I'm the Sustainable Solutions Coordinator with Green Economy London. We are joined today by Stephen Street from Woodworks Ontario to help us explore all about mass timber and how it can be used to elevate the sustainability of your projects. For a few quick housekeeping items, this webinar is being recorded so it can be posted to YouTube afterwards for those who couldn't make the session. We also have a question and answer period at the end, so if you have any questions throughout the webinar, please post your questions in the chat box. The session will begin with a quick introduction to Green Economy London, including who we are and how we are helping businesses in the London region strategize and meet their sustainability goals. This will be followed by an overview of the built environment and why it's important we consider alternative building materials to help meet climate targets. Our guest speaker, Stephen, will then discuss all things mass timber. And finally, we will finish off today's session with a question and answer period. Green Economy London is the business sustainability program hosted by the London Environmental Network, which is an environmental charitable organization based in London, Ontario, that aims to make London one of the greenest and most resilient cities in Canada through our environmental programming. We are part of the nationwide network, Green Economy Canada, who partners with organizations such as the London Environmental Network to launch green economy hubs. We currently have over 60 Green Economy London leaders and are continuously growing. Green Economy London offers a practical, cost-effective, collaborative, and community-based approach for businesses to set and achieve sustainability targets. The target areas we focus on are greenhouse gas emissions, waste reduction and diversion, water conservation, and environmental stewardship. We also support businesses through technical workshop, providing resources, funding opportunities, and celebrating achievements to showcase their commitment to sustainability. Here's a quick look at all of our current green economy leaders, who you'll see come from a variety of different sectors. I also wanted to take a moment to thank all of our supporters and sponsors who help make our programming possible. The built environment generates approximately 40% of annual global CO2 emissions. Of those total emissions, building operations such as heating and cooling are responsible for approximately 27% of emissions, while materials and construction, also known as embodied carbon, are responsible for an additional 13% of emissions every year. Unlike operational carbon emissions, which can be reduced over time with building energy upgrades and the use of renewable energy, embodied carbon emissions are locked in place as soon as a building is built. To achieve Canada's climate targets, it's important to address the emissions from embodied carbon now. By doing so, we can pave the way for a lower emission building stock in the future. As a result, there is a demand for more sustainable construction materials, methods, design, and production systems. Mass timber is stimulating the construction market in Canada as it's being recognized as a sustainable alternative to traditional practices. This is why we're excited to bring this webinar to our network to connect businesses and community members with valuable resources and experts. I would now like to introduce our speaker, Stephen Street, who will talk about the benefits of mass timber, some of the challenges in the industry, and provide insight on how you can initiate your own mass timber project. Stephen is a longtime industry advocate who has spent more than 20 years developing domestic markets for wood products by creating new opportunities, driving change, and expanding the acceptance of wood structural systems in Canada. Throughout his career, he has been around the best and brightest minds in engineering, architecture, and fabrication, an advantage that has allowed him to explore his passion for good design. Stephen is active on ResCon's technical council and is assisting in fast-tracking the workforce and skills needed to build a low-carbon Ontario. I will now pass it over to you, Stephen.
Thanks so much, Alex. Hopefully this transition will be nice and smooth. There you go. Can you see my screen? Is it sharing okay?
Yeah.
Yep, perfect. Great. Thanks so much for the introduction. You touched on a lot of key points there, Alex, and I thank you for that. Obviously, this is it's a massive subject, one I'm really happy to be here and part of this session today. We're just going to be able to touch on the tip of the iceberg, but the idea is that you know, as a network of organizations, my contact information will be there, and certainly, hopefully, we're looked on as a really valuable resource for people that are looking for wood's role in this climate situation that we're all facing now, and some of the targets that we have to face as an entire building community. So hopefully I sort of tweak some interest in some of my slides today, and I'm certainly here to follow up with you when you need the help. So I'm going to touch a little bit about what the program I work in does. Very briefly talk about mass timber and actually what it is. I'm going to cover some of the points that Alex sort of highlighted, really about the sustainability and the embodied carbon areas, and then hopefully give some very brief but practical information on some considerations that you need to take when you're looking at approaching projects. Just to finish up before the Q&A, really about some of the very recent code opportunities that have established themselves. So the Canadian Wood Council and the Woodworks program, they're technically focused organizations. We represent the structural wood products industry here in Canada. Our mandate is towards supporting the increased adoption of sustainable wood construction. How do we do this? We do this in a couple of ways. Our codes and engineering department participate in the development of building codes and standards, ensuring that any advancements in wood products and systems are accurately reflected in our building codes. That's right across the country. Our Woodworks program delivers free educational and knowledge transfer to the AECD professionals, and we help expand their understanding and knowledge for wood design and keep them current with new products and evolving building codes. We work as well with authorities having jurisdiction, as building knowledge has to include the entire building industry. And the WoodSmart program helps develop curriculum in post-secondary education institutions. I'm very excited to be here today, so thanks Alex and Miles for asking me to be a part of today. Our primary role here at Woodworks, and I head up the program here in Ontario, is project support. So we're a free technical resource. Typically, we field technical questions on products and systems, supply questions, transferring knowledge with codes and engineering support, and we get involved typically with project design meetings, sometimes doing in-house presentations on a particular topic or subject. We also do a lot of fun things. My favorite is site visits and tours. Sometimes it's easier for ideas to get across with an understanding doing a site tour, because I'm a very visual learner, and it's certainly how I learn and retain information. I know that's very important to architects and developers. We concentrate our efforts on multifamily buildings, institutional, commercial, and in the industrial sector. Just an illustration here of touring some mass timber buildings that are coming up in Toronto. The T3 Bayside project is the top image, and then the Ontario Secondary School Teachers Federation building, where I took a group of architects and developers up there with my colleague Brock. And like I say, when you see the scale and the types of buildings that potentially could be built with mass timber, sometimes a picture paints 1,000 words. We have active programs for Woodworks starting in British Columbia and Alberta, across to Ontario through the Cico Bois program in Quebec, and the Maritime 4 provinces through the MLB program of Woodworks. So getting on to actually what mass timber is. So simply put, it's an engineered product that's fabricated from dimensional lumber or engineered lumber. Laminars are laminated together to create very large structural elements. Lamination can be occurring through the use of adhesive, nails, screws, and dowels. So some of the products, basically this slide sort of illustrates sort of 6 product types: cross-laminated timber, glue laminated timber, nailed laminated timber or warehouse deck, dowel laminated timber, mass plywood panels, and LVL or laminated veneered lumber panels too. Most of you are probably familiar with glue lam. Glue laminated timber is dimensional lumber that's stacked parallel to each other, and long spans and high strength is made and fabricated from this particular approach. The dimensional lumber is stacked, glued together, and typically there are columns and beams and floor panels as well that can be made from this. Cross-laminated timber really came out of a collaboration between the academic world and industry in Europe probably 25 years ago or so, and we've steadily seen the European CLT markets, just completely take off. They've been a bit ahead of us with their knowledge about how the carbon impact buildings and building types. And cross-laminated timber is really a very viable solution to shortening the carbon footprint on buildings. And this kind of technology was then introduced into North America, probably, I think, in 2010, when the Austria House was fabricated at the Vancouver Olympics. And that was the first project that was actually built in North America. And then since then, we've seen a steady progression of buildings happen. And of course, it's the old thing, that, you sort of the chicken and the egg thing. And then now we start to have a large supply of materials spread across the country as well. So now fabricators and the interest in using this type of construction method is now building up. Nailed laminated timber. Oh, I should, cross-laminated timber, I should sort of say, this is dimensional lumber, which is really pressed together using adhesives, and it's crossed over. So each lamina is actually turned 90 degrees to the one below it to find sort of high strength, dimensionally stable products. And this is probably as close to reinforced concrete slab as you get with the two-way action that the timber elements actually create. Nailed laminated timber, this is, we've used nailed laminated timber for probably a couple of 100 years. A lot of the post and beam buildings in the downtown cores of many of our urban centers across the country have actually been used with nailed laminated timber or warehouse deck. This is dimensional lumber, basically 1.5 inches on center, nailed together using nails. And there's an illustration here on the slide of 80 Atlantic in Toronto and Liberty Village that was actually fabricated a few years ago, just to give you an indication of how it can be used with glue lam columns and beams. Dowel laminated timber is very much like nailed laminated timber, except the fastening is done with wooden hardwood dowels rather than using nails. So basically the lamina is set up 1.5 inches on center, and then a hardwood dowel, which has a different moisture content to softwoods, is put through holes that are drilled in the members. And then the dry hardwood dowel will actually take on the moisture that's inside the softwoods and actually swell. So you end up with a very high strength friction fit. So why are we talking today about mass timber elements? I think most of you know this slide, or a version of this slide. I like to call it the spectre of 2040, which is rapidly approaching us now. And it's really about the decarbonization of our built environments. Part of what our program does is watching what the industry is doing and how it's trying to evolve. So focus very much recently from many design companies that reach out to our program is very much focused on GHG emission reduction. It's part of the narrative when I've done presentations at the Ontario Association of Architects conferences. Much of it and much of the questions that we get is focused on GHG emission reduction. So it's centered on the materials. So today we're going to sort of focus on maybe some of the solutions that mass timber introduction into a build could give you. And as you see, much of the focus on this slide is about the operational reduction and the embodied carbon side, or EC. Lots going on this particular slide. The time value of carbon. On the left axis, the value that's shown is kilograms of CO2 equivalent. So embodied carbon emissions are released today. So this is as soon as you start your project, and when you get a completed building that's turned over to the client, those carbon emissions that are around the embodied carbon in the building materials are there forever, and they can't be reduced over time. It starts from the very first day of building and remains there for the entire life of the building. I like to think that's a good chance now to sort of bring in about architecture and making sure that we're using architectural design and the types of materials that really don't date. A lot of people sort of ask me about the difference between sort of European architecture and North American architecture, and why, Berlin and Vienna and London and Paris and stuff have these buildings that sort of have been there for several hundred years. It's because the architecture is good and it doesn't date. I think if you've got something that maybe is dateable in architecture, that threatens the actual building's lifespan as well. And I think we need to have to be thinking in terms of not only materials, but also how we design and what buildings look like in the future. So, as I said, buildings' life, it can be long, and operational carbon can decrease with our building energy upgrading that we do. So in terms of the operational carbon, that can shift around. And as we become better using renewable energy sources, as grids electrify, that sort of operational carbon value can decrease. Upfront carbon does actually make up the majority of the emissions that we're facing. And that sort of is highly significant. And this is why you need to be really seriously looking at how you're building and what types of materials you're actually building the buildings with. So the Canadian Green Building Council, and these two slides here were provided to me by my colleague Natasha, have put out recently these two graphs which highlight the importance of embodied carbon across two regions in Canada. So it demonstrates the distribution of operational and upfront carbon emissions over the next 30-year life cycle. And as we have to think about in Alberta, for example, they have more fossil fuel carbon intensive electrical grids. But in Ontario, our electrical grids have decarbonized over the last few years. And as our buildings become more efficient, there is a growing significance in the embodied carbon in the building materials. So it's shown in the second graph on the right. It represents a building in Ontario built around the cleaner electrical grid that we actually have here. So the data represents a building that's highly energy efficient, has electrical powered geo-exchange heating system. And the graph shows that the embodied carbon represents the majority of the building's emissions up to 2050. So the focus of the buildings in clean energy grids must be on reducing the embodied carbon of the materials. So maybe using more low carbon building materials such as mass timber solution is really a good thing, and it's a thing worth exploring. Of course, the mass timber itself has the added benefit of sequestering carbon through the growth of the timber as well. So when you start to actually think about how you can use and bring sustainable procurement into actual your buildings themselves. So one of the areas as well that's worth thinking about is actually where are you getting your products from? Where are the materials coming from? It's worth exploring this, and this is certainly where we certainly can help with materials itself. But it's like if you're getting the philosophy and the design group as well, the clients on site, you've got to be thinking local. So where am I going to get it from? Where am I going to get my materials for my project? Where are they going to, is there a big logistical footprint? Because transportation has a significant role as well to start playing on your embodied carbon initiative as well. So think about, where are the materials being fabricated? What's the material footprint as well? So maybe requesting a chain of custody certificate for the wood used in the products is viable. Various suppliers get wood sourced from different sources, and it's important to start thinking about, forestry certification. Is there an accredited sustainability forestry program and standard in use where the harvesting's coming from? And then think about EPDs, so environmental product declarations. Typically, they report the global warming potential, and they demonstrate the manufacturer's commitment to environmental transparency as well. And if you're starting to think about life cycle of the buildings as well, they can be used in that analysis, and they help to evaluate the environment, the embodied carbon of the building itself. We do have industrial average EPDs available if there is no specific EPD for the product itself. And they can really be used to achieve credits, certainly in a lot of the rating systems, such as LEED itself. So it's definitely worth exploring this. So thinking about projects themselves in the design stuff. So I think a good thing to think about is understanding the impact about the level of encapsulation and exposure on the structure itself. As architects tend to think about finishes as well, maybe instead of having a encapsulated ceiling design, for example, you may be able to expose the timber structure as well, showing the beauty of the wood, but also creating the type of aesthetics that may be very pleasing to a client as well. Residential tends to change a little bit from office buildings as well with the aesthetics. And certainly in a residential unit itself, there is the need for drywall. You want to make sure that that you're not living in a log cabin, for example. But inside an office building as well, we've seen a lot of use of exposing structure. It sort of lends itself to the aesthetics that you're trying to actually create within the building itself. So there's ways to do this. Sometimes with increasing member size as well, you eliminate the need for encapsulation requirements that the building code asks for, and you not only get the desired aesthetics, but you actually as well achieve the fire resistance ratings that you need to show in the building. Maybe eliminating access floors as well. This sort of opens up that realm of exposing the mechanical systems as well on the underside of the mass timber floor slabs as well. And just think about the environmental footprint of access floors. They add to the total embodied carbon of the entire project as well. Acoustics and sometimes you need to add mass to the mass timber elements as well. So exploring lightweight, low carbon concrete toppings is definitely worth it as you approach a project as well. We've seen a lot of setbacks as well in zoning requirements in urban centres as well. And if you can, consider eliminating those setbacks and transfer elements. Sometimes the transfer elements have a high embodied carbon, and if you're mixing them in with the mass timber as well, sometimes the great effects that you've used at reducing the embodied carbon in your project, you're actually going to eliminate that benefit by having that setback and having to transfer the elements down through, maybe with steel beams as well. Mass timber isn't good at transfers, but it's great at shifting weight through the structure when everything lines up nicely. So just something to think about. No one's particularly likes setback rules and provisions, and I think there's a movement to actually eliminate that. Definitely think about exploring a design assist contract with the mass timber supplier. What this will give you is a lot of wealth and knowledge from previous projects that people have embarked on. It allows you then to start thinking in terms of optimizing material grades and grids. And then you've got to start to think about supply as well. So not only the timber itself, but actually the connections as well that you need to connect the building together. So any of your connection suppliers should be able to be willing to come into the very early design discussions that you have. So the reduction of, maybe very complex steel and heavy connections, going towards these more high strength systems that the mass timber supplier will definitely know of, how you connect up your systems in a much more economic and maybe a better way of eliminating again the carbon equation in these types of projects. So even if you don't want to explore this design assist, you really need to know what the optimum panel sizes and supply is from the particular manufacturers, and certainly we can help with that. And I always say this is the biggest one: design the mass timber building as a mass timber building right from the beginning. It really becomes quite different when someone sort of says, well, I've designed this as a concrete and steel or whatever type of material the building's be designed is. Can you just do a similar mass timber building? Why I say this is because every material has its strengths and weaknesses, and we need to sort of really start to think about ensuring that the timber is designed as efficiently as it can be, and maximizing the benefits of actually a mass timber structure. Optimal concrete and steel bays may not be the same as an optimal timber bay. You may get that same span, but it may be done quite differently and with different materials. And again, this comes down into ceiling lines as well and exposing structures. So you've got to be aware of how these buildings are going to perform. And perform an LCA, life cycle assessment, and then you can understand the difference in the carbon impact of the building types. And then the end of life, of course, designing for deconstruction will really help promote circularity. And we need to think about, if you're bringing in that deconstructibility equation into the design of the building, we need to think about the connections. And are there rules and guidelines set at the beginning for how they perform as well in deconstruction? So decommissioning a building, obviously you want to make sure that the connections are able to be backed out, and actually the structural systems can come apart, doing less damage. And then there's the optimization then and reuse of the building itself. So simple ways of connecting things means simple construction types too. So some of the considerations, so taking just what we've been talking about, it's very important to actually start thinking in terms of, the project team. So you're going to make sure that you have the right team involved. And I always say that this is experience, have that sort of conversation with the design teams. Have you designed a wood building before? Are the engineering folks sort of well versed in how wood behaves and what types of behavior you can expect with a wood structure? So having those conversations really early on is critically important. The engineer and the architect can work very closely with the timber supplier and the client to actually give them the building that they actually want. So I think I always love the word collaboration. It's the key path to success, for sure it is. Project procurement is really important. Design and construction efficiencies required. Really, you build that around the understanding of the supply chain and what's available. And this is where a good team can kind of bring in their knowledge from past projects. And think about project location as well. Getting back to that earlier point about supply and buying local, but you need to know where your materials are coming from. Building on top of that is then, how long is it going to take me to get the product? Is it just in time delivery I'm after? What are the what's the supply? If some of these projects and these materials are 12 months out in manufacturing, which typically suits most projects. Most projects take 1 to 2 years, barring sort of approval and site plan approval, etc., to come to fruition. So making sure that you understand that supply access, that you're not going to walk down to Home Depot and actually buy mass timber elements from the lumber store either. So we're talking about sort of products that are actually fabricated, heavily CNC'd if that's required, and sort of factory fabricated as well. So think about that. And also you want to think about what types of materials, making sure that the projects aren't too complex, that you can get more than one price as well. And that obviously affects a sort of a capital cost inside the project itself. And it's always good to have competition for everything. And certainly if you can design in with widths and spans that you can get from more than one source, that's a good way of optimizing the efficiency of the structure itself. And think about mass timber structurally as well, bringing back that earlier point about maybe this is then creating that ceiling finish too, and the look and feel and the aesthetics of the building itself. You've got a significant cost saving there for finishes as well within the structure as well. As a good time to think about it too is typically your project delivery method as well, what type of contract you need to be thinking about as well. Typically we're in design, bid, build, and construction management contracts as well. Design assist is always a good one, and then we've seen a lot of use of the IPD in some shape or form, but those collaborative ways of designing buildings are always very, very good. So design development, like I say, this is, if you can get the right team established, it's fundamentally important to have these conversations very early on. And this is where you can really start to optimize the cost savings of the project itself. So think about some key things. You're using material that may be up to sort of a 25% to 33%. The mass of the building is about a quarter to a third of what you typically see with other building materials. And that's going to have substantial savings in the foundation costs as well. We're starting to see this as actually a real benefit as well as people start to explore renovation work as well. You've got existing concrete and steel structures, and maybe they're thinking about putting 2 or 3 stories of mass timber on the top of those structures. And there's still capacity in the footings and the foundations of the original buildings as well. So just something to think about for adaptive reuse. You've got advantages as well with the use of prefabrication. And that gives you really an insight into the supply and the scheduling phase of the project as well. And that will give you significant savings as well. And I've covered finishes as well. Just be aware that it isn't a commodity solution. So that front end design and building delivery effort is very much required. And this is when the pre-construction design development phase is very resource heavy. So you're bringing in the professionals maybe earlier than you have in the past. But the key to success is having that full team basically on, and this is where we've seen the success in projects. And we start to see that construction scheduling being realized. So running parallel with maybe a lot of the site work, putting in the infrastructure on the project site itself, can be running very much parallel with the fabrication inside the factory. So the day that all the site work is done with the right kind of coordination, that's the delivery period for the mass timber, and then the erection can start very, very quickly after that. And just to sort of illustrate that, in a conventional project schedule, design takes place and then the construction is long and drawn out. Typically it shifts somewhat with mass timber solutions and scheduling. A lot of work is done on the front end with the design and pre-construction phases, which incorporates the factory building as well. And then the construction phase is very much lessened. So just to bring you up to a little bit up to speed on what we can do now, back in July last year, the OBC changed, now allowing for encapsulated mass timber. A new provision was actually created inside the building code, which now is really in preparation of harmonizing our building code in here in Ontario with the national building code next year. It's supposed to be around March or April when that actually happens. And we've been in this 2-year window when the codes now start to align. So national building code allows for 12-story encapsulated mass timber provisions. And then in July, it came to play. So what is that? So it's 12 stories of height, sprinkler to NFPA 13 throughout, 2-hour required fire resistance rating, giving an area of 6,000 square meters for Group C residential and Group D office and business, 7,200 square meters. So basically, you're permitted to do C and D throughout the 12 stories. And permitted with the residential clauses, you're allowed to have a mixed-use building with Group E on the first and second story, Group A on the first, second, and third stories, and with storage garages below the 5th story. And then there's an increased fire resistance rating separation between some of the major occupants, depending on what you're bringing into the building. And for Group D, so 12 stories in height. The Group E can be first and second story, Group F, division 2 or 3, first and second stories, and then Group A, first, second, and third story. So there again, storage between below the 5th story, and then with the increased fire resistance rating, depending on what the occupancy is that you're mixing it with. So the idea is that you can now start to expand up to 12 stories, typically what encapsulated mass timber provisions allow. So what does that actually mean? We followed a key path that we did when the building code changed back in 2015, allowing for 6-story light wood frame and mass timber use in buildings in Ontario. We took the same team that we work with at Morrison Hershfield and said it's one thing to see the code evolving to allow these types of building, but actually how the design industry, and this is going right from architects to engineers to developers to builders to construction managers and the authorities having jurisdiction, what types of buildings are they actually going to see in their marketplace? So if you don't actually get to scan the barcode here, that's fine. Just drop me a note afterwards and I'll be more than happy to send you the comprehensive guide. It's about 100 pages long, but it's really how you utilize those new code provisions and maximize the opportunities that they actually bring up through the code. So is a lot of this new stuff? Not really. I think we lost our way around our wood use over probably many decades. But just an illustration here, back in 1905, this is actually in an 8-story building in Gastown in Vancouver, which is still there, still functioning very well. And it's amazing, you know, through our work and when we go and tour types of buildings like this, that you can see that there's a real efficiency on how structural engineers and architects work together, not only to create the kinds of spaces that much of this code progression is actually taking us down the avenue of, but we've seen them working for 100+ years now. And, you know, Toronto and London and Kitchener and many of the urban centres across the province here, many of our downtown cores have a lot of these types of buildings, 2, 3, 4, up to sort of 6 and 8 stories that are old post and beam buildings and still working incredibly efficiently. And it's kind of space that people actually want to move into. But unfortunately, the land that they sit on is even more valuable. So we're seeing a lot of these buildings disappearing and having, you know, 30, 40-story buildings put on the place. So it's not that the buildings aren't working anymore, it's just the land they sit on is being optimized and with high rise going on top of it. So just a couple of just projects I thought it might be worth seeing. Here's the Limberlost at George Brown College, which I was actually down yesterday at the topping off ceremony. This is a 10-story first of its kind, actually, because it's an academic institution, obviously being at the college, and it's an assembly occupancy that is the full building. That's never been done before. This was actually sort of taking the performance of mass timber and actually by the use of, I think there were 5 alternative solutions done to create this absolutely wonderful building. And if you are down in the Queens Quay area in Toronto, you should go and take a peek at it. You can see on the right there, this is actually from the street. It's up to, I think it was the 8th or 9th when we took this photograph. And then Selena actually is, I used her image there to show the 3-story glulam column, which I believe is the largest glulam column in North America to date. But it's an incredible, very sustainably driven project that Moriyama and Tashima did. On the right side there, you can see that sort of steel triangular canopy that sticks out from the side of the building, and that's actually going to be a solar chimney. So if you'd like more information on that, please reach out. And just some illustrations as well, that it's not just these large academic places that actually use mass timber. This is an industrial building that's under construction currently in Sudbury. I'm sure they've got the cladding on right now, but the client said, you know, I build industrial buildings. I want to do something that's better for the environment. So they went down the path of mass timber as well. Very simplistic, using glulam, post and beam, and then a CLT structure on the top for the various decks inside the building and the roof slab. And close to the home, if you're in the Kitchener-Waterloo area, this was a very interesting supportive housing project. Edge Architects developed it, and Element 5, who are in St. Thomas, supplied the panels for. It was a supportive housing. There's actually a second building now built next door to it on block line, block line. And really very simplistic. Again, utilizing glulam elements with CLT slab. And it really did illustrate the complete coordination between that design assist, making sure that everyone understand the potential schedule savings when the installation started. I like to sort of also illustrate on this slide as well the just-in-time delivery. The trucks came down from the factory, complete coordination with the construction management company that are actually putting the building together. And because the mass timber elements are quite light compared with other methods of building as well, there's a mobile crane too. So think about craning costs. I know if there's any developers on this particular call, they know how much craning adds to the capital cost of a build. But this is something to think about as well, because you can very early lay out exactly how many picks of product there are to actually put the building together, and that can be scheduled in for time saving and cost savings as well on the particular project itself. The facade panels in this case were mass timber elements. They were vertical, and then they were keyed into place as well. So once the structure itself was built, they just came along in a very long line and just put the panels in, and the building was closed in, I think, in about 3.5 weeks. The main structure was there, and there's actually a really good video as well of this particular project going together. So it gave you an idea that this is actually happening in the marketplace. And if you'd like more information on it, certainly please reach out to me. And thank you very much for your time. Alex, I think I'm going to stop sharing, and maybe we can, is that good? Am I back?
Yeah, thank you, Stephen.
All right.
We will head into the question and answer period now. We have a few questions. Oh boy, I can't figure out Zoom.
All right. So I can see some questions. So the first one was, I think I just actually showed some of that. The question was, are there many buildings constructed with mass timber around southwestern Ontario? So yes, there are. They're varying heights, varying uses and stuff like that. But yes, there's lots. I think I've just shown a few now. There's many others. And if anyone sort of wants any more information on potential buildings, maybe areas that they can tour it. The fascinating thing is, Alex, is that a lot of the time, once the facades go on the outside of the buildings, you don't really know what they're built with, and it's only sometimes with our kind of project outreach and that we've been involved with maybe some of the early design development work and actually helping people understand the approaching to projects that we actually know that they are mass timber. But there are a significant amount, not just obviously in southwestern Ontario, but right across the province and in many provinces across the country. So if anyone wants any more information, I think you can probably send out my contact information to people, and I can certainly help them follow up with my colleagues. Second question, how do you think mass timber will evolve over the next 10 years? Certainly, I think, this is a timely webinar to do, and I thank you again for reaching out. Certainly as we start to see, I always say the fascinating thing is there seems like a series of events that when building codes change, you start to get, how can I use this in my projects, etc. And then it's like, how is it going to perform? What are some of the things I need to think about with acoustics and stuff like that? But it's the questions definitely that we're involved with. And if we go into, maybe a design office and we do a presentation, they ask us to come in and talk about mass timber use in buildings. This embodied carbon question that you're talking about is coming up. People know that it's on that radar of that 2040 slide that I showed earlier. And obviously this is just one solution. I mean, there's, steel and concrete are going to have their solutions as well, but it's something that's on sort of mind of architects, engineers, etc. Because engineers are needed to help architects achieve the dream of using the material. So everyone is connected. It's not about one person trying to do one thing. It doesn't work. As we move as an entire building community forward, we're engaging not with just the design professionals, but also the authorities having jurisdiction, right? There has to be a knowledge transfer to them and saying, well, if I see a mass timber building, how do I need to look at it? What's the building code? And this is where, a lot of our work is done, obviously, through the Ontario Building Officials Association as well. It's about, keeping the authorities having jurisdiction up with what's actually happening in the design world. So when the building code evolves, and back in July last year, it created that new encapsulated mass timber provision within the building code for many different building opportunities now. We almost have to sort of help everyone with a knowledge transfer as well, that we're going to start to see these actually coming. You might see them coming across your desk in design principles or for permit review or stuff like that. So the entire movement as an industry has to move forward together. And then, of course, the installation, right? We have to think about the skills needed on construction sites to actually put the buildings together. And this is, this is ever evolving. There's lots of great companies that do great work as well, and all of that needs to be coordinated. So I'm very excited as well where it's going. It's good. So I think I answered that one.
Just in the interest of time, because we're almost at the end, would you just be able to answer one more?
Yeah, sure.
The question, could mass timber be used to add a second story to a warehouse built of concrete block and steel beam?
Yes, as long as the capacity in the foundations and the structure that's there is able to take the weight. So obviously you'd need to do the engineering review of the existing building to make sure that the capacity is there, and then the loads and basically the layout exactly that you want the building to look like will be there. So I would say yes, but you need to have structural review of the existing structure to help that happen. The advantage of going with wood is the weight of the material itself. So if anything can do it, a wood system, whether it's light framing or mass timber, can do it as well.
Awesome. Thank you
That's
so
where
much.
your engineer needs to come in. Yeah, for sure.
So that wraps up today's webinar. I wanted to thank everyone for tuning in today. We hope that you learned something new about mass timber and will consider implementing it in future projects. I finally want to thank Stephen for taking time out of his busy day to join us. And if anyone has any questions or would like to join Green Economy London, my email is on the screen, or you can reach out to our Director of Sustainability, Caitlin. Thank you and have a great afternoon.
Thanks, Alex. Thank you, everyone. Bye-bye.